Hey there. So now we're going to go ahead and talk about I/O, or input and output. We're going to talk about what it is, how it's done in Python, either using the terminal, files, or dialog boxes. We're not going to talk about dialog boxes, but just know they exist. They're not really going to be pertinent to what we're doing now. So if you're really curious about them, I can try to work up some examples. Just let me know. But they're not what we need to focus on. And then there's different kinds of I/O. It could be text, binary, or raw. So I/O, as I mentioned, is input output. It is at the basis of pretty much how how we as humans interact with computers, how we as programs or users input something to a program, and how we get something out. So right now you're probably sitting at a computer in front of your keyboard and mouse and a screen. Keyboard and mouse are input devices. The screen is essentially an output device. It's outputting things from your computer to the screen so you can see it whenever you click anything. That's a form of input. When you enter like a text box, that's an input. Yeah. Um, it's all encompassing. So how is it done in Python? It's done in a variety of fashions. The most basic and often used is input from the console. So we quickly talked about the terminal in the first lecture where I just ran through running a Python file there. But it's also kind of what you might think of in a movie when you see a stereotypical hacker sitting in front of a black screen with some text flying by. They're sitting in front of a terminal, and usually for movies, terminals running a program to output random things, so it looks impressive. Terminal, console, shell, and command line are all terms you may have heard. They are often used interchangeably. They have differences to each other, but if you want the further explanation, you can go ahead and go to this link. You should have access to these files by now, and I'm not going to talk about all the differences, but if you're curious, they're there. Python also has the ability to read and write to and from files. This is how the majority of data handling will happen for YStack via the opening. Oh, not opening. Excuse me. You know what? Doesn't matter for the lecture. I apologize for my typos. But we're mostly going to be doing opening files to read it in. As I mentioned, it also has dialog boxes, but we're not going to really touch this for the PD. So why is I/O so important? It's how data is given to and received from the program. Without I/O, your program would run without telling you the results and without any put from yourself or from you. There are some programs that do that. There's programs that just kind of run and do their own thing, and we as users don't need to know what they're doing as long as they're doing it. That's fine, but for the majority of what our purpose is, we're going to kind of want to know what results our program finds. Otherwise, what's the point? So I/O can be done in a variety of fashions, as I mentioned earlier. It could be text-based. You might read in bits or bytes, or you have raw inputs. So text-based I/O deals with strings. We talked about strings in the variable lecture, but they're groups of characters, which are just groups of data. You might have it in a text file, and your program will read it in and work with what was stored or print out. We'll do that a little later on. By I/O, files are stored as a collection of ones and zeros. This option lets uh, your program read in byte data. So a byte is 8 bits, a bit is a 1 or a 0, and fun fact for you, 4 bits is a nibble. I'm sure someone cracked themselves up when they thought about that. It is also spelled with a Y to work with. This is your program pulling in just the bytes. So I don't know if any of you have heard of the term steganography before, but it's essentially the not the people who type up court documents, but it is the act of hiding a message in a plain to see fashion. So one of the coolest ways to do this is if you have like a picture, you can go through and modify the least significant bit in your picture, 8 bytes at a time, just taking off the bit to store data in there. So I've have a program to where I take a picture of my dog and I go through and I store Ragtime Cowboy Joe in there. And then when you look at the picture, it looks exactly the same as the unmodified picture because the least significant bit is aptly named because it doesn't really change a whole lot about the color or anything of the picture. So you can do that to hide things in there. That might be why you want to read in the byte data. Raw IO is pretty similar to byte reading. It's used for low level building blocks. We're not really going to be touching raw IO in this PD that I can imagine. Maybe you guys can find a reason to and you want to, and we'll go ahead figure it out. It just doesn't have a buffer. Yeah. So let's go ahead and look at some of the examples for this. So this one's kind of pointless by now because, again, of how circular the foundations are, but printing hello world, that's our basic output. It's as easy to do that. It doesn't have to be a string. On the variable lecture, we printed X, which was a variable of an integer type. So you can do it with a variety of things. You could also like put a comma in here and say, go pokes. And look, it put those together. You can print multiple things in your print statement. Oh, go poke. Gotta fix that. Go pokes. Okay. We can also get input. So you call the input function, and again, we haven't done functions yet. But what this does is it allows us to input our name, and it'll print it back out. So when we run it, you can see it types in something for us to type in, or it pops up something for us to type into. I'm going to type in my name, Danny. Here's our input, and it outputs, hi there, Danny. IO, simple as that. More helpful, though, is the use of files, and especially for this where we're going to be dealing with data sets and things, that we're going to pull those from a file, probably from Kaggle, and we're going to need to open and close them. So I already have an example file in this directory ready to go. When you open files, you have to make sure how you're doing it. You might need to supply a path to the file if they're not in the same directory as the notebook you're working in. Luckily for us, we can see over here example.txt exists in the same place as io.ipython notepad, and we're good to go. So we can go ahead and run this. It opens it up, it prints out the text, and just in case you guys don't believe me, example.txt, hello YStack participants. Cool. We're also able to write out too. So let's go ahead and we're gonna just delete this out.txt. It's gone. It's no longer there. So what we're going to do is we're going to open it up. We're going to write something. We're going to prompt a user for input just so I'm doing this live for you guys so you can see I'm not fudging anything, and we're going to close it back out. Okay, so what would we like to write? And we're going to say, I hope you all enjoy YStack. Do that, and we're gonna write it out, and we can come in here out.txt. I hope you all enjoy YStack, and then again we can do that pragmatically in our program, bring it back up. Cool. So that's kind of just the very basics of input and output. I know I'm touching on these things quickly, so if you need any further explanations or more in-depth overview, just reach out, let me know, and I'll be happy to get you to where you need to be.